G'day guys, it's the Aussie Engineer here and welcome to another video in the Intro to Python series. This series aims to teach you how to code in Python in easy to manage blocks. Today our tutorial is on understanding data types and variables in Python. In this video we'll cover the basics of how Python handles different types of data and how we can store and manipulate that data using variables. So, in Python, data types refers to the different kinds of data we can work with, such as numbers, strings, and Boolean values. Each data type has its own properties and behaviors, and it's important to understand how they work so we can effectively use them in our programs. The following are some of the data types, and we'll be covering each of these today. Integers, floating point numbers, complex numbers, strings, lists, tuples, Boolean values, dictionaries, and then finally we'll be finishing on sets. We will cover an example of each of these, as I've said. Variables are used to store values of data in memory, and they can be assigned new values as needed. In Python, variables are dynamically typed, which means that their data type can change at runtime depending on the type of data they are assigned. For example, a variable can be assigned an integer value and later reassigned a string value without the need to specify its type. Variables are like containers that we can use to store and manipulate data in our programs. We can assign values to variables and then use those variables throughout our code to perform operations and make decisions. We can perform arithmetic operations on these types of data, such as addition, subtraction, multiplication, and division. So let's have a look at some of the different variable types through some coding examples. So let's move across to our Python examples now. Okay, the first type is the integer type. In Python, integers, int, are built in numeric data type that represent whole numbers. They can be positive, negative, or zero, and they can have any length up to the limit of the computer's memory. Here are some examples of how to create integers in Python. In this example, x, y, and z are all integers with values 10, -5, and 0 respectively. Notice how we use fstring to print the output. If you missed what this is, there is an earlier video in the series on fstring. So let's just run this code to see what it outputs down the bottom. We can perform arithmetic operations on integers such as addition, subtraction, multiplication, and division, just like we can with floating point numbers. In Python 3, integer division using the slash operator always returns a floating point number, whilst integer division using the double slash returns the quotient of the division without the remainder. And here are two examples of this. Noting that one with the single slash, the first one, outputs 3.3 recurring, whilst the double slash returns the integer value without the remainder being an answer of 3. Integers are used in a wide range of applications, including mathematics, science computing, and computer programming, and they are often used to count and represent quantities that are in the whole numbers. Okay, next. The next type is the float type. In Python, floating point numbers, float, are built-in numeric data type that represent real numbers with the decimal point. They can be positive, negative, or 0, and can have varying lengths of precision depending on the size of the number and the computer's memory. Here are some examples of how to create floating point numbers in Python. In this example, x, y, and z are all floating point numbers with values of 3.14, -2.5, and 0.0 respectively. Let's run the code to show that output. And as you can see down the bottom, x is 3.14, y is -2.5, and z is 0.0. We can perform arithmetic arithmetic operations on floating point numbers such as addition, subtraction, multiplication, and division, just like we can with integers. However, it's important to note that floating point numbers can be subject to rounding errors and other limitations due to the way they are represented in computer memory. As a result, it is generally recommended to avoid using floating point numbers for exact comparisons or calculations where precision is critical. Floating point numbers are used in a variety of applications, including scientific computing, engineering, and finance. They are often used to represent quantities that have a fractional component, such as measurements or percentages. Moving on next to complex type. And this is the same as complex numbers in mathematics. In Python, complex numbers are a built-in numeric data type that represent numbers with both a real and an imaginary part. A complex number is written in the form a plus bj, where a is the real part and b is the imaginary part. And j is the imaginary unit which satisfies the equation j squared equals -1. Here is an example of how to create a complex number in Python. And we'll run that code just now. In this example, z is the complex number with a real part of 5 and an imaginary part of 7. We can perform arithmetic operations on complex numbers such as addition, subtraction, multiplication, and division, just like we can with integers and floating point numbers. We can also assess the real and imaginary parts of a complex number using the .real and .imag attributes respectively. And as you can see here, we are printing the z.real and printing the z.imaginary. Complex numbers are used in a variety of applications, including signal processing, control systems, and scientific computing. In Python, they are often used in mathematical and scientific libraries like NumPy and SciPy to perform complex calculations. Okay, moving on now to strings. In Python, strings, str, are a built-in data type that represents a sequence of characters. They are used to represent textual data such as words, sentences, and paragraphs, and can be enclosed in the single quotes or double quotes, depending on the programmer's preference. Here are some examples of how to create strings in Python. Now let's run that code, and we'll talk about the outputs. In this example, greeting, name, and message are all strings with values hello world, Alice, and nice to meet you, Alice, respectively. We can concatenate strings using the plus operator, which will combine the contents of two or more strings into a single string. Strings in Python are immutable, which means that once a string is created, it cannot be modified. However, we can create new strings based on existing strings using slicing and other operations. And here are some examples. In this example, fruit is a string with the value banana. We can assess individual characters of the string using indexation starting at 0, or we can extract a substring using slicing, which extracts a range of characters from within that string. Strings are used in a wide range of applications, including text processing, web documents, and data analysis. They are a fundamental building block of many programs, and understanding how to work with strings is an important skill for any Python programmer. Next, we'll move on to the list type. In Python, lists are a built-in data type that represents a collection of values. They contain any combination of data types, including numbers, strings, and other lists, and can be modified, i.e. they are mutable after they are created. Here are some examples of how to create strings in Python. Now let's run that code. In this example, numbers and fruits and mixed lists are all lists with different combinations of values. We can perform a variety of operations on lists, including adding or removing elements, assessing individual elements using indexing, and slicing to extract a subset of elements. Here are some examples, and you can see the effects from the print outputs. Lists are used in a wide range of applications, including data processing, machine learning, and web development. They are a versatile and powerful tool for representing collections of data in Python programs. Moving on to tuples. In Python, tuples are a built-in data type that represents an ordered, immutable sequence of values. Like lists, tuples contain any combination of data types, including numbers, strings, and other tuples. Here are some examples of how to create tuples in Python. Let's run that code. In this example, coordinates, person, and nested tuple are all tuples which are with different combinations of values. Tuples are immutable, which means once they are created, their contents cannot be modified. However, we can create new tuples based on existing tuples using slicing and other operations. Here are some examples. In this example, we use tuple unpacking to assign values of coordinates to the variables x and y. We can also use slicing to create a new tuple containing the first two elements of coordinates. Tuples are often used to represent collections of related data that should not be modified once they're created, such as coordinates of a point or the name and age of a person. They are a useful tool for organizing data in a Python program. And as per here, we can see that the new coordinates, more coordinates, lists the numbers from 1 to 6. If we take the first two values of that into first two, it will then extract 1 and 2 into a new tuple, which is called first two. All right, moving on now to booleans. In Python, boolean values, bool, are a built-in data type that represents a binary value, either true or false. They are used to represent logical values in a program and are an essential component of control flow statements such as if and while loops. Here are some examples of boolean values in Python. Now let me run that code. In this example, x is assigned the value of true and y is assigned the value of false. Boolean values can be combined using logical operators such as and, or, and not to create more complex expressions. For example, in this example, the AND operator combines two Boolean expressions to create a more complex expression that evaluates to true, because both expressions are true. Boolean values are often used in conditional statements to control the flow of a program based upon the values of a certain variable or expressions. They are a fundamental tool for creating robust and flexible programs in Python. In this example, in the second part, you'll see that we've now assigned a value of 5 to x and 10 to y, and then we're assessing. And this assessment here will output a Boolean. If x is less than 10, it is because it's 5, therefore this will equal true. The second part, y greater than 5, y is 10, so therefore this will equal true. And true will output true, which is what we can see down the bottom. In the next video in the series, I'll cover some of the logic output diagrams to using and, or, and not statements, so you can have a look at what is output by the system when we are doing this. But moving on, let's get into dictionaries. In Python, dictionaries are a built-in data type that represents a collection of key value pairs. Each key in a dictionary maps to a corresponding value, similar to how words in a dictionary map to their definitions. Dictionaries are unordered, which means that the order in which the key value pairs are stored is not guaranteed. Here are some examples of how to create dictionaries in Python. We'll run that code now. In this example, person is a dictionary with 3 value pairs: name, that maps to the string Alice, age maps to the integer 25, and city maps to the string Boston. Empty dic is an empty dictionary with no key value pairs. Dictionaries are mutable, which means that we can add, remove, modify key value pairs after they are created. We can also access the values of a dictionary using its keys. Here are some examples. In this example, we modify the key value of age key and add a new key value pair for job and remove the city key value pair using the del keyword. Dictionaries are often used to represent complex data structures in Python, such as tables of data or networks of relationships between objects. They're a powerful tool for organizing and manipulating data in a Python program. And we can see in this code up here that in this, when we're recreating the person dictionary, it has initially an age that's set to 25 in the key value pair. We're now setting it to 26. And to do that, you use the square brackets with the key in between those square brackets. We can then add a new one by basically by specifying a key which is not previously used, and then we can delete a key by using the del command as indicated here. Lastly, this part of the code here pulls out the value and displays the value for the age key inside that person dictionary. Okay, so on to now our last data type for today, and that is sets. In Python, sets are a built-in data type that represents a collection of unique elements. Unlike lists and tuples, sets do not allow duplicate elements, which means that each element in a set is unique. Here are some examples of how to create sets in Python, noting the use of the keyword set. Let's run that code now. And you can see up here that set is used to set a set. All right. In this example, S1 is a set of integers from 1 to 6, S2 is a set of strings representing the fruit names, and S3 is an empty set. Sets are mutable, which means that we can add or remove elements after they are created. We can also perform set operations such as union, insertion, and difference to combine or compare sets, and here are some examples of that. In this example, we add an element to S1 using the add method, and then perform set operations using the union, intersection, and difference methods. And we can see the outputs of each of these down below. So firstly, adding a new value. So set1 is 1, 2, 3. We then come in and then add an element to the end of it, which gives us 1, 2, 3, 4. When we can run the union, so set1 union set2, this will then output the union of the two sets, which is all of the values of set1 and set2 combined to create a new set. The intersection, which is numbers in this instance which are in both set1 and set2. And then lastly, difference, which is what are the elements that are not common to the two sets. Sets are often used to perform operations on collections of data that need to be unique, such as finding unique values in a data set or removing duplicates from a list. They are a powerful tool for managing data in a Python program. All right, guys, so there you have it, an introduction to the data types and variables in Python. By understanding these concepts, you'll be well on your way to writing powerful and flexible programs in Python. Be sure to practice working with these concepts on your own, and stay tuned for the next video in the series, being control flow and loops in Python. As always, guys, remember to like the video if it was useful, and subscribe to the channel so that you can be notified as soon as the next video in this series is released. Guys, as always, good luck with your Python journey and stay safe out there.